with the difference quotient. It's actually a bit simpler than it sounds. So what is the difference quotient? Well, the difference quotient is something that we use to help find slopes of a function. So if we have a given function, like this one, f of x equals 3x plus 2, and we want to approximate the slope. Well, most of you should know, based on the form of this, that the slope is going to be 3. So if our approximation doesn't come out close to 3, we know it messed up somehow. So our difference quotient is given by this formula here. How do we get this formula? Well, most of you should remember the formula for finding the slope in general, which would be y2 minus y1 over x2 minus x1. Well, you should all realize that f of x is essentially the same thing as y. So f of x plus h is at y a little bit to the right. So we've moved over h, and that gives us a new height. Now, what's useful is our new x is x plus h, our old x is just x, so when we subtract them, we just get h. So that's where the formula is coming from. So I suggest using dq to reference the fact that it's the difference quotient. Now, the first part is f of x plus h, so wherever there's x, put in x plus h. And make sure that if you're doing any squared or anything like that, it's happening to the x plus h as a whole, not just to the x. Then you have to subtract your original function. When you subtract it, you may need to make sure that the negative goes onto all parts of it, so it gets distributed to everything. With a little bit of simplification, we get the difference quotient is 3. Pretty useful. So it can come out and tell us what a slope is for a linear function. There are some other advantages to this. So let's take a look at this. We have the difference quotient plugged in already, which when we evaluate it for this function, it comes out at 3. Pretty nice. But what happens when, instead of just a basic linear function, we're dealing with squared? Well, when you look at this, over here, it's a decreasing function, so we'll have a negative slope. Over here, it's a positive function, so we'll have a positive slope. So what's that mean? That means our difference quotient will actually change based on the x value. So let's go ahead and turn this on. And you see that our slope for the approximate's changing as we go along. But unfortunately, if you look close, over here it should have a negative value because it's a decreasing function. But the difference quotient is a positive number. Why is this? Well, it turns out it's because of this h. Because the closer you are to your x value, the more likely you are to be correct. So our h is currently 1, which means for this x value, was starting here, going over 1, and using this as our second point. So we're measuring this slope that's getting dragged by the mouse, which, as you can probably guess, wouldn't be very accurate since it actually should be going down. So let's go ahead and make this a 0.1. Well, you now see that we have a negative slope on things over here. So it's actually much better representation. So in general, the size of the h, the smaller it is, the better approximation this will be. If any of you continue on into higher mathematics beyond this, you'll see different examples of using it. But for now, just know that the difference quotient can be used to approximate our slope. I hope you enjoyed the video. See you in class.